Okay, we are gonna work on hyperbolas. So, if you saw the basketball I had on my Padlet, the edges, well, like the curved part, you know, where it like kind of caves in, that's a hyperbola. And I measured it, like you saw, and it was 2.5 inches wide and 3 inches tall, or vertical, or in length, I mean. So, what we're going to do is we're going to find an equation for the basketball. And it's a hyperbola, because you know the way it looks. So, the standard formula for a hyperbola is x minus h squared over a squared minus y minus k squared over b squared is equal to 1. So, I decided it would be best to put the center of the circle, which is, the hyperbola, at point 0, 0, so it is easiest to tell how far away everything is. So there are two foci on this hyperbola, and those are negative 1.250 and 1.250. So you can see, I'm sorry the graph is kind of messy. I would recommend looking at my graph on Desmos in the Padlet, because it will best show you this hyperbola. So here's the first foci, here's the second foci, and the middle here, this is the center, and that is point 0, 0. So the center is halfway in between the foci. Okay. So, the center being 0, 0 tells us that in the equation, the h value and the k value are both 0. So that means it's x minus 0 squared over a squared and y minus 0 squared over b squared. So we're going to look back at the graph, and we're going to look to find the a and b values. So you can see in my graph, there's this box right here. So like it's an invisible box, but I drew it on there. So from the center to the right of the foci, going horizontal, is the a value. So the a value is equal to 1.25. And the b value, you can find that by going from the center to the top, and the b value is equal to 1.5. So knowing those two values, the formula for that hyperbola, and oh, by the way, it was in horizontal formula, because the way I had it was done, it was horizontal. So there's a vertical formula and a horizontal formula for hyperbolas. So if it's vertical, here I'll show you a picture. It'll go like that, or if it's horizontal, it'll go like that. Alright, so the formula for that hyperbola was x minus 0 squared over 1.25 squared minus y minus 0 squared over 1.5 squared is equal to 1. And make sure if you graph it in Desmos, you have the equal to 1, or else the graph won't work. Okay, let's go back to the graph. So if you can see these two dotted lines, they're the asymptotes, and they are both oblique asymptotes because they're diagonal. So to find the asymptotes, the equation is y equals plus or minus b over a times x minus h plus k. So we plug in all our values and we get y is equal to plus or minus 5 over 1.25 x minus 0, or times x minus 0, or let me restate that. Plus or minus 5 over 1.25 times x minus 0 plus 0. Okay, so if you plug that in for both the plus and minus equations, the plus equation is y equals 1.2x, and the minus is y equals negative 1.2x. So those are your two oblique asymptotes. So if you see this box, a lot of things seem to be centered around this box. So the asymptotes will go through the center of the hyperbola, which is also the center of the box. So, and then you see here, there's also a C value. So from the distance from here to here is the C value. And the C value, well, you can find that out from the foci, because the foci is h, k plus or minus c. So you put the y value is equal to k plus or minus c. So, or you put the two y values. So let's go. The negative 1.25 is the minus, so you don't have to worry about the 0, because that's already in there. So oh, my bad, I put that wrong. So it's h plus or minus c, comma, k. I'm sorry if I confused you on that, but mental mistakes. Alright, so h is equal to 0. So h plus c is equal to 1.25. So 0 plus c is equal to 1.25. So c is equal to 1.25. And if you also do it as h minus c is equal, you can also do it as h minus c is equal to negative 1.25. And c is equal to c, that would be, and h is 0, so it would be negative c is equal to negative 1.25, and c would also end up to be 1.25. So there's your c value right there. And that's a wrap.